So my name is Sophie. I'm a software engineer on the product team here at HubSpot, and I'm going to be your host for tonight. Just a few things before we start for real. If you have any questions or concerns, you can reach out to the team. We all have the blue t-shirt with the logo on it, so we'll be very happy to help you. Second thing is the talks are going to get recorded, and we're going to put them online later, so stay tuned. And finally, if you want to become a speaker for our next event, there's a form on the Meetup website, or you can talk to us directly, and we'll be very happy to have you as the next speaker. But yeah, let's start for real now. We have three amazing speakers tonight, Adrian, Lorcan, and Maria. And please join me in welcoming our first speaker, Adrian, who's going to talk about localization in softwares.
Hello, so I'm Adrian. I'm a software developer. I've been working at HubSpot for just about a year now. And in this time, I have improved my latte art and GIF making skills. This has been my main job while I was here. Right, but today, I'm not going to be talking about that. I'll be talking about localizing software. And there's a few things that go into localization. First of all, you have to think about how do I support different versions of the same text in different languages? And then you also have to concern yourself with how do I actually show my UI in the different regions? Because cultural differences will affect the way that you're supposed to design your UI. And then there's the whole technical part of like, how do you actually build a system to allow us to do this? And the reason I care so much about localization is because this is my name. This is my full legal name. And apparently it's an edge case in 80% of the software out there in the world. So it has a hyphen. It has a special character there that's... Can I? No. It has a special character there that's not on an English or on a Turkish keyboard, which makes sense because it's a Romanian name and that's a Romanian character. And you can find it on our keyboards, but you can't find those keyboards, which is usually a problem because I don't think even our government uses them. And yeah, most of the time I end up writing my name like this. And the reason I do this is because it's simply not supported. Hyphens are normally not accepted in names. And then if I replace it with a space, the website goes, blah, you can't do that. So I'm like, OK, I'll put it in the middle name field. That one doesn't exist on a lot of websites. And then, my sh in my name, because it's Visan, gets rendered like that, the E with an accent and trademark, which is pretty cool to have a trademark in your name, but I don't actually have it. So moving on. And I can accept that from some small forum on the internet. And, I go on these sites of the internet, there's like 10,000 people on a forum talking about how to modify a game that no one has been playing for 15 years, because that's what I do in my free time. But I have different standards from my government. So on the top there, that's how I'm supposed to legally spell my name. In the middle, it's the way it's on my passport. That S Sedila there, that's a Turkish character. That's not a Romanian character. And even weirder, the last line, Bucharest, that's the city where I make my passport. That's on the same page on as my name, and it has the correct character on my passport. So on the same page in the passport, they're using two different alphabets, which is amazing to me. Even cooler still, I've had 3 passports, and so far, each time, they wrote it differently. The second time they got it right, employee of the month right there, I tell you. But the first time when I saw it like that, I was like, it's fine. I just made my passport to go over to the US quickly. But in the visa application form for the US visa, they have a field for your name in its original spelling, which is very nice of them, because then you can have a spelling that the border agents in the US can understand, and you also have a spelling, your correct spelling. And then when I went over and I met one of these border agents for the first time in my life, because in that field I put my name how you're supposed to spell it correctly, they decided my passport is a fake, so I had to deal with that. So if you're working with software for anything to do with government work, please localize it. Right, so all I'm trying to say is that localization is hard. It's not something that you just do. It's not easy, but it's not technically hard. It's not hard from the perspective of, oh, how do I code this? The questions that you get on interviews are going to be much harder than the implementations that you need to solve this sort of things. It's hard because you have to think about certain aspects of different languages and cultures that aren't common in your original language. So you might be wondering, okay, why do I care about this, right? There's over 1 billion English speakers in the world. That's a large enough market. Done. Well, not everyone speaks English, and software doesn't have the same distribution limitations as physical goods. So it does reach everyone. It isn't just stop at borders. So you're limiting your market by how many people you address. The more you localize your software, the more markets you can reach, and the more people will use your software. Regardless that you want profit or you want to change the world, you will be limited by the same thing. Okay, so what do we do? Like I was saying earlier, we have to support localized text, we have to take into account the differences in cultures, and then we also have to support localized dynamic content. And by dynamic content, I mean anything that you provide the UI for people to put stuff in, and then it appears in your application. So this is something like, your PMs might want a UI where they can put, okay, what updates have happened since last time. That's what I mean by dynamic content. So localizing static text should be the easiest, right? It's straightforward. It's just text, I replace it with something else. And we start from something like this, print text, and then magically we have text on the screen. Let's imagine that this is a valid syntax in an imaginary language, and we can continue on from there. But then we're like, okay, that's not going to work to localize. We want to make it support multiple languages. So we decide, okay, we extract our text, we put it in some external resource, and then we take the user's language, and we get this as a variable, and then we print that. And after writing this for about 200 times, you realize that it should have always been this. And the method should resolve the language itself, and then, render the text. And then, the resource would be something like this, a YAML file specifying exactly what each different key should mean. And then it's very easy. I copy this, send it to a translator, it gets translated, I get it back, put it in my application, and hocus pocus, I support another language. Okay, but what happens to conditional text? Because it's not always static text. Like sometimes I want to say a message, to give a message that depends on a certain situation. Like for example, I want to tell someone you have this many unread messages in my application. And the direct approach would be to do string concatenation, right? Again, let's just imagine that this is valid in that language. And it would just bunch the text together. So what happens? So in English, it's fine. We have one unread message, 200 messages. Great. Problem is, in other languages, it might not work. Romanian, here it's kind of fine, because it's the same subject, verb, object order. So ai un mesaj necitit, ai două mesaje necitite, and that's where it starts cracking. Because in Romanian, you pluralize associated words as well, not only the word that's being counted. So string concatenation won't work as easily. And you might be like, okay, I have pluralization rules. I can handle that in that system. But then you go over to Japanese, and it's a subject-object-verb language. So that goes out the window. You cannot do that for every language. And then you can notice that the pluralization marker is the same in Japanese for 1 and 2. That's because it's a counter. So it's tsu. When you count inanimate objects, in Japanese you count itsu, nitsu, 1, 2. Right. If it's people, you're supposed to put there ri. So itsu would become hitori, and nitsu would become futari, because that's how we count in Japanese. It goes a bit wonky. And it becomes quite dangerous to not treat this case, because today I received an email about how many attendees I'm going to have. If it were Japanese, and instead of the marker for people, they would have used the marker for food items, it would have been a bit awkward to read that email. So we have to take these sorts of cases into account. And the best thing to do is to use placeholders for these variables and send it to your translators with the placeholders and tell them, do not touch them, move them where they're supposed to be, and add extra context for the translators so they know what it is, what it means in the sentence, what use it has. Of course, this means that you'll have a different one for the plural case. And you might be wondering, how far can this go? Well, at one point, I was building something in our UI, and because of the different conditions, I ended up having about 4 dozen variants of the same sentence. And at that point, you go back to the designer and you're like, please, can I just have a single sentence and the variable outside of the sentence? And he was like, yes. I was like, thank you. Because supporting that is a lot of work. So then I was mentioning cultural conventions, right? Why do we care about them? What do I mean by that? Well, one of the more obvious ones is name order, because you have first name, last name, prenome, nume, and then the family name and given name in Japanese. I'm not going to attempt to read them. And this order is very important, because people don't usually read the forms. They write it all their lives in a certain order. They just write it that way. And if you use Chrome to fill in those fields, it will just fill them in the same order. So this can be problematic. You might not kill people, except if you build software for hospitals. In that case, it might happen, but hopefully not. But it's still going to be a problem for some people, because receipts might not be accepted if the name is not in the proper order in that culture. And then they'll have to go back into the software, change the name, update it, and reprint everything. Right, and then there's other concepts like formality. So in our system, we allow users to associate their inbox with their account so that we can do analytics on the emails that they're sending, which is great. And then to test that out, so you don't have to use a second email or ask someone to reply to your email, we have this thing called Cool Robot that you send it a test message, and it replies to you, which is fairly cool. And in English, we just go by first name. Hi, Adrian, that's fine. But in other languages, that's not accepted. You have to be more formal. In Japanese, you would use last name. In German, you'll use last name. So you have to take into account that things like this will be affected by culture, and you have to also support that. Right, so what about the translators? They're the key part in this. They're the ones that are doing most of the work. They go through all of the text, localize, take context into account. But that's key for them, context. They need as much context as they can get. And the comments, like we showed earlier, explaining what the usage is very important, especially in cases where words have more than one meaning, right? Like back in English. It can mean my back or go back. And in Romanian, that's spate for my back and înapoi for go back. And if they see that word in isolation, there's no way for them to know which one to use. Same in Japanese. It's senaka and kaeru. And I put the ones between brackets, which are for primary school students, because I can read at grade 2 in Japanese. That's all I can do. Right, but for them, screenshots are the best, because screenshots will give them more context than just what's it used for. It will tell them, hey, this is a button, so translators will know, don't make the text too long because it's going to explode. Or they'll see the limits, or they'll see, okay, this sentence is 3 times on this page. How about I always translate it the same so that it's consistent? And these are great, but the problem is it's not always possible to provide screenshots, especially for dynamic content, unless you create a system that opens your applications, go to that page, takes a screenshot and sends it, which is possible, but it is a lot of work. So what did we do? How did we use this? How did we take this into account? So when I joined HubSpot, the first project I was put on was the Learning Center, or Academy, or Athena. It's had identity issues, but it's the Learning Center. And one of the first things I had to do was to make sure that we support the same content in multiple languages. So the idea is the user should be able to complete something, or they've already completed something in one language, but when it gets translated to their native language, it should already be marked as completed, right? We should keep track of this across different languages. And it should be easy for them to switch languages. And because it's learning materials, we do fall back, so if a lesson is not translated, they see it in English in the meantime, until it gets translated. And it's free to our users. It's about our product, but it's also about marketing and sales in general. So it's not like it's not useful for people that aren't our clients. And it's a project that I really enjoyed. And we had to think about, okay, how do we translate things? So we have create an update in English. Our professors work in English mainly. And then we request a translation. You receive a translation. It has to be validated because it's a lot of content. And because we're telling people what's the best approach for their business, we have to make sure that we're telling them the correct thing in other languages as well. And then we publish that translation. And in order to achieve this, what we decided to do was to separate out the storage between whatever is common, like we had a few seconds ago, the tags at the bottom, and then like those would be the topics here, and the content that's associated with the lesson. Those things are always the same. But then the lesson name and description, those are localized fields, so they're stored separately. So we would have one table for everything that's common and a separate table for each lesson, for each language, with those specific fields. Another way of doing this would be to have a key saved in your DB, and then the other table just be language, key, and translation. Great. And then we also have an internal translation system, right? An internal translation service. And then the Learning Center pushes information there. But these you don't just make a request, you don't do a post and you immediately get a response. I mean, you should, that's how APIs should communicate, but you won't get the translation. Translations take time. If you want good quality translations, you still have to use human translations. The text I had earlier in Japanese, if I added or removed the S at the end, it completely changed the sentence and the structure of it. Machine translation is not there yet. So you would have like a pooling mechanism or a queue, or the other service can push to each individual service. It's not really a concern in terms of performance, so it doesn't really matter how you do it. Right, and then from the internal translation service, you either have internal translators or you use an external translation service that you push out to, and it gets translated. And the reason we use an intermediary is because we do microservice architecture, which is a version of SOA, so you have multiple services, and you just keep this responsibility in one place. And yeah, I was saying, they don't return immediately, so what do you do? What do you do when you have a new feature that's not translated? Well, these are like fallback options, right? So there's a few of them. You can not show the feature at all to anyone until you have the translations, right? You can show it to English users, but not to other users. Depending on the domain you operate, that actually might be illegal. You can prompt the user and tell them, hey, here is English only. It's up to you if you want to see it. Or you can just render English as a fallback. But asta ar fi a very jarring experience pentru orice persoană care ar încerca to use your features când traducerile nu sunt complete. Right? That's kind of how it feels to use software when it's not fully translated, when you have bits and pieces everywhere. You have to think about this experience for your users, because some of them are bilingual, like I am, but some of them won't speak English or whatever language you're developing your application in, and it's not going to be great for them. Right, and then at the end, so we receive the translations. What do we do in the Learning Center? Well, we have a UI with people that are qualified, so that means someone that speaks that language and also understands the content, to review the content and then say, okay, this can go out. And you can see here, English and Spanish were released, but German isn't ready yet, because the lesson teaser was not translated at this time. This is the current state in our system. So that makes it very simple. But you might be wondering now, okay, that sounds like a lot of things that I have to think about for that specific user base. So who do I talk to? Well, in your team or company, or maybe even in your user base, you probably have some like support reps or account managers or anything of the sorts, right? People that interact with those clients on a frequent basis. And they will have the context, because as an English speaker, usually you can't really understand that, right? Even if you're coming from a different language. Because you can't really understand that pain of not being able to use an application because of a language, because of that barrier. Because most software nowadays is written initially in English. And for them, it's very hard. And you need someone that interacts with them often enough to be able to properly understand them. And you might have the technical solutions, like you'll be able to solve these easily, but they will tell you what the problems are that you have to solve for. Yeah, that's it. Questions? No?
How many languages your platform support?
Our system?
Yeah. And why these particular languages were selected? Oh,
so the question is, how many languages do we support and why those particular languages? In terms of languages, right now, I can probably open it. I think it's English, French, German, Spanish, Japanese, and Portuguese is in beta. These are the languages that we support for our customers. For our customers, we have another 10 languages that we support, so they can send to other languages. I don't know that list. And I cannot answer why those particular languages. I'm not in that position.
Will be a good fallback solution to use machine translation, but have a tag somewhere showing that to the user until a human translated text replace it.
Yeah, that's an option. It can work. Like, there's nothing stopping people from falling. From falling back to machine translation. What I would say is do that for where it's not business critical. So don't do it for payments and things like this, right? Some of the things you can't do that, like payments, or if you're dealing with someone's health, probably not a good idea. Other things, yeah, it's probably fine.
I mean, is all translations done manually? I mean, isn't there any kind of machine translation at all, or are you building a system at the back end where it learns from those manual translations and then tries to go ahead with machine translation?
Okay. So the question was if we use only manual translations or if we do any automated translations. I can answer that quite clearly. We've tried using automated translations and the quality has been very low. The feedback from our international customers has been nothing but negative, so we decided to just give it an extra day or two and have actual translations and pay that difference. Okay.
Hey, Adrian. So what's, in your experience, the biggest hurdle for new beginners in coding to address localization? Is there like a cultural barrier to entry, or is it like non-native speakers have a better way in because they're familiar with like trouble with their passports, etc.?
Oh, the biggest problem with translations. There's two big problems. One, most software doesn't start out localized. Second, if your PM is native English, they will not understand the problems and they will push against prioritizing them. So prioritizing translations usually doesn't end up being too well. It goes at the back. I've worked in 3 companies and translations have always been like done way too late when we had to rewrite way too much of the system to reintroduce them. Okay, I think that's it for now. Thank you so much.
Thanks, Adrian. If you have any more questions, don't hesitate to reach out to Adrian at the end. He's going to be at the networking session, so feel free to talk to him. And next, we're going to welcome Lorcan, who's going to talk about the technology stack and lots of things. Welcome, Lorcan.
Hello? All right, cool. I've never played with these fancy mics before, so be gentle with me. And I've also never played with... Ooh, there we are. All right, I've got a bit of control now. All right, thank you very much. For years, I thought as an Irish person, I had the most difficulties when it came to all things localization because I have an apostrophe in my name. And airlines, banks, Facebook, briefly, hated me for it. And then Adrian joined my team when he came to HubSpot last year. And, well, he taught me a thing or two about how privileged I was with my Western European name. Okay, so what am I going to talk to you about? Well, I'm going to start by telling you who I am. I'm a senior software engineer in HubSpot. I work on our Service Hub product group, which builds customer service and customer support tooling. And the team I specifically work on is our feedback team, which builds survey software for our customers to their customers. Tell you a little bit what I'm going to talk about, my preface and my motivations. Talk to you about the title. Pragmatic system design, how your technology stack can impact on it, lest you think I was being glib and glossing over it. I'm going to tell you what a pragmatic system is and why I think it's important and why it's definitely not a made-up term that I came up with a month ago. I'm going to talk to you about the different aspects of what I think a pragmatic system is in terms of like build, deploy, and validate and how these tie into the engineering process and how people interact with the engineering process. I'll have a couple of calls to action, some resources, which are basically things smarter people than me wrote that I stole from, and time for any questions that you have. So, What are my motivations for giving this talk? I'm a Java engineer, and I work on customer-facing product for a software-as-a-service company. That's what HubSpot is. We build a suite of marketing and sales tools. I'll go into more detail on that in a second. But it's the fact that we're a software-as-a-service company that I think particularly makes the topics I'm going to touch on interesting. I'm going to frame system discussion in terms of feature development and feature variance and how the way we work impacts on that. And I'm going to tell you a bit about the way my team has to decide what to build. We make a lot of decisions about what we're going to build. Some of these get to be data-driven, which is nice. Some of them have to be based on more qualitative feedback when customers who we really trust in terms of the situations they're in tell us about extreme pain points that our software causes them. Some of these are based on feature parity with people who are in similar fields to what we're doing. It's a competitive market out there. There are 5,000 different options in the marketing automation field. Some of them are gut decisions, and they're the ones that people will never admit that they make, but sometimes you do. Sometimes you make gut decisions on what you're going to build. The constant across all of these is that they benefit from us being able to pivot quickly in order to verify any of the assumptions that we have. Finally, I will clarify that this is a very scattershot collection of thoughts. You can pick and choose as you want from them. They're incomplete, they're non-authoritative, they are not gospel, and they're highly opinionated. So feel free to criticize me and tell me I'm wrong at the end. So, what is HubSpot, and what is a software-as-a-service model in of itself? So as I said, HubSpot is a full stack of marketing, sales, and customer service software powered off of a centralized CRM. And it operates as software-as-a-service, which is software which is hosted or distributed online and accessed on a subscription basis. The difference that tends to happen with software-as-a-service models, as opposed to the more enterprisey software solutions, is that they generally benefit from the pace at which they can iterate and release software. This is opposed to, say, more enterprise solutions that have restrictions in terms of how often they can restrict, SLAs that they have to meet, or controls over the accepted level of quality or uptime that their customers might have of them. So, what is a pragmatic system, and how does it play into this? My definition of a pragmatic system is one which actively minimizes friction when you try to make changes to it. And it's one which acknowledges the transience and the volatility of modern software-as-a-service solutions as they exist in tandem with the needs of their customers. Effectively, no code that you write is perfect, and no code you write is going to remain unchanged for an indefinite period of time. And it's about embracing that and acknowledging that within certain fields, you're going to have to constantly change and adapt to the market in which your software is operating. The other key thing I think makes pragmatic systems important is that they strive to be built using the same technologies that their applications are built in, and I'll delve more into that later. So just to frame how this works within the software-as-a-service model, it thrives on the speed of its innovation. And I'm kind of framing this against the idea of agile methodologies and agile approaches to building software. And I think that they've tended to focus more on the delegation and prioritization of the work units themselves. I don't think that necessarily correlates with the systems on which agile software are actually being built, being optimized for this kind of adaptability. There's kind of a dissonance between the design and the implementation. And at the core of it, I think there's one question that matters really more than anything else, which is what enables me to get the best software in front of customers in the shortest amount of time. And best here is offered with a caveat. There is no best that is catch-all. Best is always going to apply more specifically to the situation that your team is working in. So let's talk about what kind of barriers software engineers face when they need to make changes to the software they're working on. They face a build problem, which is I've had to completely rewrite things in order to handle the proposed changes that my team wants to implement. They suffer from deploy issues, where it is difficult or time-consuming for them to actually get something released. And they suffer from a validation problem. And I think this can be the most key part of it, which is not knowing whether or not your changes have made a difference to the system that you're working on. So let's walk through these one by one and see how these tie together in terms of how some technology choices or implementation details can help us build systems that best massage these three different areas. With build, we think, how can I easily change the behavior of my software without impeding the work and behavior of anyone else, and what techniques or patterns can help to achieve this? So the first thing I'm going to talk about is dependency injection, and how dependency injection can help with this. At the end of the day, dependency injection is just a really fancy term for giving objects instant variables. But if we're going to be less glib about it, it's a mechanism that decouples the notion of who is responsible for building objects that you want to use within a piece of object-oriented software. It hands the responsibility for resolving that construction away to something else outside of the code that's calling it. Examples of these would be the Spring Framework in Java, Managed Extensibility Framework in .NET, Juice, which is also Java. You may be seeing a theme. I am a Java engineer. I know more about Java than other languages. Or Dagger, which is also Java, but for Android, so at least that sounds kind of different. Through the use of appropriate interfaces or abstractions when you're thinking about how you're going to build together a system, you can leverage dependency injection to make it possible for you to modify how your system behaves through the simple addition of new code and the use of configuration to tweak what code paths get executed. So I'm going to give you an example using Juice, because that's what we mainly use in HubSpot. And this is completely not contrived and definitely did happen at some point. So let's say that my team is a feature which selects a group of customers that we want to offer a coupon to. And it's currently using MySQL as its backing store. We love MySQL at HubSpot. And because a customer complains about the speed of this particular feature, and because we've seen some really distressing query metrics coming up in our logs, we decide that we're going to test using Elasticsearch to make this change and see how it operates. So let's hark back to the earlier question. How can we expand on this in a way which impedes other development as little as possible? So start with something like an interface that just says, I want to retrieve the coupon recipients, and a little void method that spits out who am I, because I love when software is opinionated and tells you its name. We could put together a MySQL implementation of this, which will wrap the functionality that decides using our MySQL data store who we should send these coupons to. As you can see, I have not put together a MySQL implementation, but yeah. We can also put together then an Elasticsearch implementation of it, which similarly under the hood will have its own independent business logic, but will have the same signature and can plug in at any point where the MySQL one could. So if we look then at something like a Juice module, which is the heart of how dependency injection works, what we have here is a piece of code which tells the rest of our system which object should I provide to you in a particular case. This is what you're handing the responsibility off to. So this piece of code has a method in it that says, I'm going to give you back this selector, this coupon recipient selector, that you can use to decide if it's going to be Elasticsearch or if it's going to be MySQL. So what I've done in this case is I have it using a system environment variable with the very catchy name of Pragmatic System Design Coupon Recipient Selector Type, which is the main reason I'm not allowed to name any variables in our projects anymore. And it decides based on that if it's going to pivot between this Elasticsearch or this MySQL selector. And then we put together a little main method, which is just going to use a Juice injector, which is the primary way that you ask it for instances of your variables. We ask it, give me this coupon recipient selector, and it will choose to do something with it then. So that's our code, and this code is going to remain constant between the two different instances of what we're going to execute here, because we're going to provide one instance with a runtime variable saying, you should use MySQL. The other one, we're going to provide an environment variable saying, you should use Elasticsearch. And lo and behold, the MySQL selector that I definitely didn't hard code that time into is really, really slow, and the Elasticsearch one is really, really fast. And my project manager is going to be really happy with me because we've managed to prove our hypothesis without having to fuck around with the code base too much. This could be deployed in isolation. This is the beauty of it, to some instance of our application, powered solely by a different runtime variable, and it's possible for my coworker, Eduardo, wherever you are, he can go off and try and solve our MySQL issues. We're both leveraging the same code base, and we're managing to not tread on each other's toes while we're doing so. This transitions nicely into a kind of a tandem idea about how you can control your software without having to make binary changes to it, which is the notion of how flags and configuration can help power an application that is capable of pivoting. So they collectively attempt to achieve a similar goal to what dependency injection should. Can we modify the system behavior without having to change the code that is executing? This is really powerful if you want to validate assumptions within control settings, like what do a certain cohort of our users experience, or what happens during particular times of day, or when Mercury is in retrograde, or whatever crazy set of criteria that you, knowing your product best, would be able to apply. They let you test beta software, which may still need work, or which may not be ready for the unwashed masses to try out, and preferably, and this is probably the key part of it, that they are live. They're capable of updating without you needing to restart processes or make binary changes or in other ways modify your software to get them out there. So let's talk about some examples of how configuration works within software. Let's say that my friend John has provided us with a search client that our team is going to use. And this client expects us to package a particularly named YAML file into our binary in order to configure it. Or Sarah, who's provided us with this nice string-to-object parser, but it expects you to include VM arguments if you want to change some of its behaviors within the processes command. Niall has put together a router that we're going to use to balance traffic to our database shards, but it expects particular environment variables to be defined for it to be configured. Or Annabelle, who's given us this lovely collection of currency converters that require an API call on startup in order to configure themselves. What are some issues with how these configuration examples work? First off, they are static in terms of how they're created and how they're configured, but more importantly, they are all different, and they present different barriers to the consumer, who is the engineer in this case, to interpret how they should be used and how they can modify their usage of them. Some of them have a dependency on a code base, some have a dependency on the process's configuration, and some have a dependency on the run environment itself. What are some golden rules that I think we should have then when we think about configuration and feature flags? The first off is that you should strive to standardize how your engineers access configuration. If you provide one pattern in how you access configuration, you can make it consistent. There is less of a cognitive load for your engineers to understand how do I configure things, and it makes it possible for you to strive for excellence in terms of how that particular form of configuration is executed. You should make it live. It should be possible for it to change mid-code path, so that you can alternate things depending on times of the day or depending on what you're trying to test at a given time. And it should be decoupled as much as is possible from your code base, from your execution command, even from your runtime, if you can. So what are some useful pieces of technology that people use to try and achieve these goals? You can use Apache Zookeeper, which combines this centralized configuration and synchronization service with a hierarchical key value store. This is something that we use at HubSpot for some of our configuration. You could use Hollow, which is a Netflix library, which is capable of having a producer-consumer mechanism where you update a data set in one place, and there's many read-only consumers that have locally cached versions of it. This is probably powering most of your entertainment at the weekend in terms of your preferences or, shitty horror movies that you've already watched, but you're going to go back to because it's Halloween, and you're like, what else am I going to watch? And BoJack is already finished, or something like that. Or Console, which is a service mesh, which similarly has this kind of hierarchical key value store. And interestingly, it can be powered off an HTTP API, which makes it quite easy for people to plug in and play with. What about HubSpot? Do HubSpot use these kind of things? Yeah, we've got some feature flags, feature sets. I'm going to use an example here, which is one we have, which is called gates. Gates are just a collection of feature flags. You associate the flag with a customer. If the customer has a flag, you want the thing to happen. These are made available to all of our front-end applications as part of a standard HTTP request that executes on page load for a customer. This means our engineers don't actually worry about how they're going to retrieve or access these. They're made available to them very easily, and we don't force them to put in any extra effort to be able to access things that let them configure their application. Similarly, we've got internal tooling that allows our product managers, user researchers, or anyone who's interested in messing with what customers see, are capable of updating these, configuring them, or trying out different combinations. The final thing that I'd like to dwell on a little bit as regards the build process and how pragmatic systems and build are tied together is about incremental improvement and how through the use of things like dependency injection and feature flags, it allows you to mock up non-scalable solutions really quickly without having to create interfaces that are non-intuitive. And I think the non-scalable part is really important here. If you spend time working on scale and performance of code that never gets used or which leaves production, that can be considered in some cases time that has been wasted or energy that has been wasted. If you use the correct interfaces and planning about how you're going to build your system, it's possible for the signature to remain the same while you can worry about behavior and performance at a later point. So let's go with another case study, which definitely also did happen, I guarantee. This is Cambria. Cambria is our product manager. And Cambria comes to me and says, I'm interested in trialing a feature where we'll survey our customer after they've signed up. We're going to send them an email. Maybe at a later point, we'll give them some prompts in app. We're going to send them push notifications, text message, carrier pigeon. I'm not going to try and block her creative ideas, but that seemed a bit extreme for me. We get a lot of signups, though. That's the key thing. So this is probably going to need to be something that can scale, be processed in parallel, maybe queues, something like that. So we spend a few weeks building up an architecture. This is capable of queuing lots of messages and distributing them across an architecture where they can be processed by many different consumers. We have the perfect post-sign-up framework. And then we find out that, based on user research and initial beta, like inklings, the feature's inconclusive in terms of the impact we wanted to have. We're going to remove it, and we're going to focus our efforts elsewhere. Wasted time, wasted energy, sad panda. What if we took the same approach that I discussed earlier on, and we were to build something like a post-sign-up processor interface? This has one method. It decides, I'm going to process whatever your sign-up is. We can make a couple of implementations of this. First one just makes a synchronous HTTP request and sends an email. This meets like the initial definition of we want to do something after this happens. Similarly, we could come along a week later and go, this is working really well. In fact, too well. These requests are building up and we're using too many threads and people are getting slowed down. We'll build a queue. Okay, so now we're just going to queue up a message and we'll let that be processed somewhere asynchronously. We'll use something like SQS or RabbitMQ. And then we jump forward a month where the feature's doing really, really well. Okay, now we can just plug in a multi-queue approach, which is going to queue it up to something like Kafka, where we're going to have multiple consumers. Then we can start worrying about the kind of structure that we're going to need for brokering that, and all these different consumers and how they're going to interact with each other. But more importantly, we worry about the problem when we need to. We don't worry about it preemptively. And this code, which is the code that's going to run, will not change at any point during this entire derivation process. You'll tell it, you need to get a post-signup processor and execute against a signup, and it'll choose which of them to do depending on what stage we are in the ideation process. This lets you get something prototypical in front of your customers really quickly, and it postpones building something more scalable until you need it, and it makes integrating that updated functionality a lot easier after the fact. It means your system can incrementally improve as it needs to. Will this scale is, I think, the most misused phrase across all product development. I have friends who do not work in software who ask me, will it scale? And I want to punch every single one of them. I think it's important to realize that scale is important, but fetishizing scale because it's a cool engineering thing is the wrong thing to do. Not everything needs to scale at a particular time. And I think you got to think sometimes, I ain't going to need it. I need to prioritize what my decisions are in this case, and sometimes you need to prioritize getting something in front of a customer that you can try out. So let's talk about deploy. How does the deploy process play into pragmatic systems and how they're hooked up? I think all the benefits that have been accrued from these design patterns that I've discussed with you are nullified if it becomes time-consuming or awkward for you to get your changes into a production environment. You should ensure that your engineers have full control over their own deployables. I would advocate for microservices, a service-oriented architecture. Why is this? Well, let's start with some simple reasons. If you have a monolithic architecture, there's going to be more actors in it. There's going to be more variance, and there's going to be more at stake if a deploy of it goes wrong. This increases the amount of coordination that's needed to get that software out, and the complexity of analyzing how change sets are potentially going to impact on currently working software. You should empower your engineers to be able to do deploys themselves. Why do I think this is important? If you have to hand something over to a DevOps team, you're introducing delays automatically into the system. You're also introducing dissonance because your production engineers need to be able to communicate particular context about, well, we're going to release this API, then we're going to run this job, and then we're going to release the API again with this change that needs the job to be reflected. This creates like its own layer of complexity. I once worked in a company where you had to email a guy a zip like 3 days in advance, and then he'd disappear into a dark room to upload them over SCP. This really happened. I'm not joking. It was painful. On a separate note, though, this not only restricts the pace that your changes get released at, but it contributes to variance between like your local dev environment and what is currently in production. Like if you've got a release cycle that's a couple of weeks and it's 12 days into that, there's a major bug in production, but you've got 12 days worth of a backlog of changes sitting on various branches scattered around. This can really lend to friction when you're trying to work out, all right, I'm going to have to try and fix this bug, but how do I get my software into the same kind of position that it was when we deployed that 2 weeks ago? The final two things that we dwell on here are your processes should be stateless and disposable, fast to start up, and graceful to shut down. And these are important because they enable you to scale horizontally, because the process itself is not important. Processes can be replaced at any given point. It lets you plug and play instances of this process with as little pain as possible. You also have to ask yourself, how much does a restart cost you? What happens if you have a cluster management system that wants to reallocate resources? What happens if you're frantically firefighting a bug, which is causing massive customer pain, and you're having to make deploy after deploy after deploy because it's a weird quirk about how it behaves in production, specifically on IE6? Is IE6 still a thing? I think IE6 is still a thing. God, they said the future will be wonderful. They lied. Your processes taking a long time to go up or to go down is going to frustrate your engineers. It makes change expensive. And if change is expensive, then people fear change, and that's not good. So, what's some tooling that you can use for the kind of the deploy part of this to help enable your engineers to be able to deploy in a more free-form manner? You could use something like Kubernetes, which we use at HubSpot, open source container orchestration system, basically managing lots of computers, virtualized computers, small computers, all sorts of computers. Docker Swarm, which is clustering and scheduling for the Docker container mechanism, or Apache Mesos, which is this open source tooling for managing different clusters of computers. And this is an interesting one because frameworks can plug in over this functionality and allow their own level of overlay. HubSpot Singularity is one of these, which is the open source tooling that we use to link the deploy and run process of how we release software. So, what do these kind of deploys actually look like? If you had this kind of free form, it should be easy for an engineer to decide they want to release a piece of code at any given time. I asked my tech lead if I could do this beforehand, lest anyone think that this is irresponsible of me. And these are my changes, so it should be OK. This is Orion, which is HubSpot's own internal deploy tool. And I'm asking it to deploy 2 different APIs. And it's going to provide me with some commit checks, dependencies. I can see a code change from the last time it went out, except I'm not logged in. OK, that's good. And I can click deploy. And it'll go out onto production. And this is going to go and do a lot of work that previously people might have had to manage themselves. I've worked in companies where you have to bring up your load balancer, bring down your load balancer, put instances in and out, make sure that you've got different derivations of config running on one or the other. What this is doing it's doing a lot of the heavy lifting in a way that is not completely abstracted, but is suitably abstracted that I have control over it, and I'm not having to get someone else to go do the work for me. This is important if I've got changes that are timely or that require some degree of management. I'm not having to coordinate unnecessarily with someone else to get this done. Now, the question is, can I get this back up again without breaking it? Success. Seriously, this is the bit I was most worried about. All right, so last thing I'm going to talk about is validation. How does validation play into the pragmatic system process? 2 key things, product value metrics and product performance metrics, and why you should be paying attention to both. Product value metrics are going to be things like your key performance indicators. How many people use the features you build? How many users get value from your product? Your performance metrics are things that are probably a little more bare bones or a little more easy to designate across different companies because there'll be things like how does your API respond at the 99th? How much data can you process asynchronously? All that kind of stuff. But both of them have value. And being able to confirm both of them is key to building a flywheel about how you work with your system and how changes you make to your system drive changes that you make to your system. So, what are some rules I think you could apply in these kind of cases? Where applicable, you should establish timeframes and metrics that you want to use to validate changes and schedule it so that you don't forget to check up on these. When I say schedule, I don't mean you got to do a monthly retrospective. I don't mean that there needs to be like a 4-page wiki article on it. This can be as simple as write a reminder in Slack saying, go check out that your code change worked, or have a note in your agenda for a stand-up. Similarly, your validation should be aware of deploys, releases, and variance within your metrics. If you can do this, it makes it easier for you to associate regressions or improvements much, much easier. People are really, really visual. If I look at a diagram that says, chart goes up, and at point chart went up, thing happened, I'll usually think thing happened because chart went up, or chart went up because thing happened. Yeah, that's cause and effect, not effect and cause. Trying to infer those without those kind of visual aids can be quite difficult. So having this kind of information associated with it makes it really, really powerful for you. You should standardize how your teams are actually tracking and reporting their findings. This is empowering because it enables cross-team findings. You can have centralized resources that they're all leveraging. But more importantly, I think having all of your teams reading from the same hint sheet removes something that's already difficult. Like, communicating is hard. Try communicating when you're using different data sources. Like, my numbers are more important than yours. My data source is different to yours. You end up having an argument that's not the argument you want to have. You want to talk about how you can work in your numbers together, not where did your numbers come from. And finally, you should let the results feed back into the priorities, because if you're not acting on your numbers, then you have to question, why do you care about them in the first place? So, 2 quick examples of things that we use in HubSpot to validate assumptions and changes that we make to our system. This is Amplitude. Amplitude is a product analytics vendor that we use. Our PMs and our engineers work in tandem to decide what is important, what should we capture. This is a snapshot of a diagram. The diagram was tracking a thing that we did. But you can see it's overlaid. It has this nice little event on it saying, at the point where the number went up, we started using this new variant of sign-up flow. So we have a starting point for inferring this is why a change happened. More importantly, we can now go back and go, all right, well, what will happen if we try this, or try this, or try this? That's product value. Product performance, we use a tool called Signal Effects. So we get a lot of this information generated for free on our Java deploys, which will give us lots of useful information like performance of a resource, performance of database connections, and those arrows are pointing to deploys. Those diamonds are deploys that we put out in the last week on our particular set of APIs, which you can tie to Git commits, like make endpoints way faster, which I really should have done months ago. I got in a lot of trouble for not taking out all those thread.sleep calls that I put in. And we can tie it directly then to the deploy that happened on October 22nd. That's when number went up and to the right. So these are like some shallow enough examples, but they orchestrate how having deploy information annotated within the validation metrics you're looking at makes it easier to identify patterns. So what are some calls to action that I have after that 20 minutes of thrown together thoughts? First off, you should examine whether or not your product is one which would benefit from this kind of rapid iteration and release cycle. It's not going to suit every particular business or even businesses at a particular stage in their growth. You should ask yourself what barriers your engineering teams face when they're iterating quickly and identify whether or not your systems are currently responsible for that. If so, investigate changes that you can make to rectify that. And finally, you should let your product be what drives your processes rather than the other way around. Don't try to fit the way you build products to various things that people have told you while they've been standing at the top of a room. I'm aware of the irony of this. You think about the way that your product needs to be built, how quickly you need to be able to change and adapt to what your customers need. And based off that, you work out the rules and techniques that enable your team to be as productive as possible. Some quick final thoughts, because these did not fit neatly anywhere into it. Pragmatic systems should not only strive to remove these visible frictions, like how hard is it for me to change things or get things out or discover if things worked, but they also need to minimize mental friction. Teams that can work quickly and fail quickly and iterate quickly, they're not afraid to make decisions. They're not afraid to fail. And if you remove the fear of failure, it's one of the most empowering things that you can do for an engineer. The greatest gift I would give my younger self, naive and callow as he was to stop treating software as something that always had to be perfect and accept that the only constant in life is change. Software changes, and learning how to adapt to that is what's going to make you a better engineer. Maybe a better person. I'm not going to say that strongly, but probably a better engineer. These are some things I read. They'll be available on the slides if anyone wants them afterwards. They're mostly clever. And that's me done. Thank you very much. Any questions?
How do you make sure you get rid of the flags afterwards?
As in feature flags that you've added?
Like, how do you make sure that someone goes and cleans them up and you don't find them 5 years later?
There are members of our authentication and app systems team over in Cambridge who would love to know the answer to that question. There was a point where we were carrying around megabytes of payload of flags that didn't matter at that point in time. I think there's just a general practice of hoping that people will have good housekeeping and clean up after themselves. I think we also have an email that detects if a flag hasn't been updated in a month and sends you like a narky prompt going, "Oi, clean up your mess, buddy," or something like that. I don't get those anymore though, because I'm fastidious. I clean up after myself.
Can you also tell about your testing framework? I think that part you missed up as a part of continuous deployment.
Yeah, that's a good question, and I think it was just that I had a little bit more content than I expected, so I didn't end up focusing on anything related to testing. HubSpot has a kind of a holistic attitude to it, where we expect people to want to test their own code as much as possible. We provide a lot of tooling for that in terms of there's integrated unit testing frameworks, we have an integrated acceptance test frameworks, but teams find the right fit for it themselves, and we don't have a QA department. We don't have a team who are going to audit your code for you and make sure it's working. It's a combination of know the right level for your software. So like if you're writing billing software, you test every edge case. If you're writing something that generates signatures for like a fun little side project that we're doing, you probably don't need to check that it renders all the emojis correctly. Just most of them will do. But yeah, each team kind of right-sizes it for themselves. So we know the key critical code paths on the stuff we work on. We focus extensively on them. I don't worry about what happens if somebody sends me, what did you call it? An S with a squiggle on it? Yeah, I don't worry about Adrian's surname is effectively what I'm saying.
And how about the metrics? Do your product management worry about the metrics in terms of quality, in terms of testing output?
Well, that's the thing. I mean, if your tests are all passing, then that's 100% a good metric, isn't it? We actually have prompts that will actively stop you from deploying. They'll say, by the way, buddy, your tests are failing, maybe don't deploy. And there's an opt-out where you say, I know the test is failing because John committed a variable with the wrong name, but the logic is still solid in a production environment, so I'm going to skip it for now. It's cool. I don't think we focus really as much on the metrics of testing, because testing is just supposed to validate the code works in isolation. The metrics that we care most about are what happens when we unleash it in the world and they do strange things with it.
And a last question. I mean, do you also take coverage into perspective?
Pardon?
Coverage?
Courage?
Yeah, coverage.
Oh, coverage.
Yeah.
Sorry. I was I just talked about bravery. How did courage come up again already? I think it's a similar idea. I mean, I've run code coverage on portions of our base, and I've gone, we're not at 100, but that's probably okay. What are the code paths I care about? I probably want close to 100% on those. I don't think we try to fetishize it. In a similar way to the stuff I talked about with scale, where we don't necessarily think about scale when we don't have to. You don't think about having 100% code coverage if it's not going to be essential to making sure your app works in the key and critical parts that it should. Thank you very much.
Thanks, Lorcan. So our next talk will be Maria. She's joining us from Indeed, so we're very happy to have her on board today. So please join me welcoming Maria. She's going to talk about data analytics.
Yes, okay. I'm going to talk about data analytics. Yep, so that's the wrong way. There we go. Who is this human? This one. Here. So, I'm Maria. Actually, following on from the first talk, I've actually changed my legal name so that it is 2 tokens of all ASCII characters. It was easier than the paperwork. I'm reasonably enthusiastic about data in that I'm very happy when graphs happen and I get to play with data, but I won't corner you in a pub. It is entirely your own fault that you asked me to come here. I've spent time playing with robots. At the moment, I work as a BI analyst. That does not mean that I play with Excel. I have worked as a dev. I write Python code, generally. Cool. So, I would only be talking to you if there was a problem, right? In the land of software, when you have a bug which you have already tried to escape, it doesn't tend to make it onto the news. In this situation, I'm talking about bugs not just, I wrote a function and it should print foo, but it prints bar. I'm talking about 4 different kinds of problems, broadly. Problems with requirements, is in that we built entirely the wrong thing for mystery reasons, and here to use it anyway. Problems of input, which is a small part of software, so maybe you have to validate some input, make sure that there's SQL code that is not running directly on your database, but is a very large problem with data analysis, because most of the stuff you're dealing with as input is massive amounts of data. Probably you would like that to not be silly. Modeling errors, which I'm going to tie kind of to regular unit testing and code. And then testing. Okay, you can have bugs in a unit test, but it's a really, really small amount of code, and you're probably not going to have a bug in a unit test, hopefully, and eventually you would find that. Testing for data analysis is sometimes a little silly, and sometimes we're testing for the wrong things, and sometimes we're testing incorrectly. I realized that I didn't put in a slide about this, but I'm talking to a bunch of engineers, and just for the idea of what I usually do at work, I wanted to go through it. So usually someone comes along to me and they say something approximately like the other way. They say something approximately like this. Those are my requirements. Apparently I'm supposed to go off and take those requirements, find some data anywhere, lying around, doesn't really matter. Write something that has a lot of buzzwords in it. So I used to work in deep learning. I notionally still can, but it's not great all the time to do so. And write a report that says, yes, we have really, really good p-values and the accuracy is extremely high. There's a problem with this, right? So probably we should solve problems that we kind of know about with data that we have a vague hint of it working and being sensible, and the answer should be something that we're kind of expecting. So for the rest of the talk, I'm going to go through first keeping your bugs off the 9 o'clock news. I'm going to go through the news, some sort of dated news so that I can actually have understanding of what went wrong. And I'm going to go through, for the stories, there's 4 or 5 of them, what kind of bugs happened, so whether it was requirements or input or output or the actual process being wrong. And then after we've gone through a lot of depressing news where, oh no, you did something wrong at work and now you're on the news, we'll go into how not to do that instead. Okay, so I finally pressed the right button. This guy was in the news a year or so ago. So Microsoft decided that because it's really cool to do data analytics stuff, that they would put a chatbot on Twitter. The chatbot was supposed to behave like a teenage girl, and it was supposed to learn about the world and chat to people on Twitter. It went slightly awry. And this is kind of an example of, okay, first of all, requirements. Why did you build this? Also, for the input, you didn't do any validation. You put this defenseless AI on the internet where people are really mean, and you said, hey, you should learn to be like those people. It's fine, take in all of the input. And so after a day or two, the thing was pulled off the internet because they had realized that, yeah, it'd be really fun if I was just a jerk to everyone online. So this is a failure of testing your input data and probably of your requirements. So the second one is frequently in the news, but in small amounts of news, because there's a bunch of different companies doing it. This is Minority Report. Yeah, okay. So there are companies definitely in India and China, and mostly I've heard in America, although they tend to be research arms of government in America, who are putting neural networks, because we all love buzzwords, and neural networks are cool, onto CCTV cameras to try and predict crime or try to divert police to, like, hey, we think probably in the future, like half an hour, you might need to be in this area. The requirements for this are reasonable in theory. So the requirements are, hey, we have like limited police resources. We would like the police resources to go to wherever they need to be. That's okay. The input is kind of the problem here again. So the input is, we know all of these people we arrested. That's probably a totally fair and representative sampling. We definitely didn't misarrest anyone. And there's no criminals out there we didn't catch. So we're going to look at video of them, and we're going to continue to assume that people who've previously been arrested for crimes are definitely the people doing future crimes. So you might get into problems where, like, beards might be a really common feature of criminals if you didn't maybe validate the bias in your in your input data. Also, the modeling of these particularly is a little bit concerning because CCTV cameras have very, very tiny processors, so you have to make the model simpler in order to actually run it. So you're probably going to have some errors there. Since they're mostly researchers, I test them to do the output and the validation. Okay, this definitely made the news, so I'm going to just go through what this was. There was a news item a couple of years ago, and it actually has been partially misreported. So there was a teenager in America who shopped at Target and who got targeted emails. She went shopping. That was great. Her dad got one of the targeted emails, and it was recommending baby stuff and like new mother pregnancy stuff. And he called Target going, hey, my daughter's not pregnant. How are you insinuating that we are not wonderful people and like she's like a teenager and this is never going to happen? Turned out she was pregnant, and he apologized. This is usually reported as, oh no, the robots are so scary because they have realized things before we do. Realistically, what probably happened was that when we were modeling things, we decided people who want to buy baby stuff are in this pile over here, and people who don't want to buy baby stuff are in this pile over here. And probably she fell somewhere in the middle because she's a girl, she's right the age, and she may have bought some kid stuff, but maybe it was for her friends. It was probably not that the AI was scarily smart. It was probably that the model was kind of uncertain, and it erred on the side of probably all teenagers are pregnant. That's actually a really easy thing to bias in a model if you want to do it yourself. So you don't have to just run a model. You don't have to just download it from TensorFlow and go, yep, that works. You can tune parameters so that you can have errors be more or less likely on the false positive, false negative. There's also this one. GDPR has saved you from this one. unless you go to America or other countries. Okay, so because of GDPR saving you from this one, it didn't get as much press in Europe. Last year, I think, they were definitely working on it 2 years ago, so it may have been more recent than that. Facebook decided that it was bad that people were sad on the internet, and they should be happier on the internet. Notionally, that sounds lovely. But they decided that they were going to analyze people's emotions, and if you seemed like you might be suicidal or depressed, they were going to, I know the people who were working on it, so they were considering telling people, but that would have actually violated privacy. So they were going to re-rig your user interface to try and work out, hey, can we make you happier by showing you more kittens, etc. On the requirements phase of this, because I talked to the people who developed it, and they did not catch the requirements phase of it. That should never have happened. You're trying to change someone's emotions because you think it's probably good, but they haven't opted into it. And you're trying to do it in particularly dangerous situations where you actually think this person is at risk. For input, their input data also has a problem. Facebook have lots of your data. They don't have a complete worldview of exactly how you behave, so they don't know if the problem is actually that you're seeing too many kittens on Facebook. They don't know if it's a problem where one of your friends is bullying you in real life and you don't want to see their picture anymore. For the modeling, their modeling actually looked really cool, and their testing was relatively okay. So, also, this is not a targeted news item. This is the last news item I'll go through before I go through, hey, can we do better? But you get op-eds like this frequently. And I couldn't find any kind of clear-cut example where it was as obvious as the other ones. For, hey, think about people when you're writing stuff that analyzes loads of data at a time and then pushes that change out to everyone, mostly automatically. But there are a lot of op-eds kind of going, hey, we should hire chief ethics officers. We should hire basically babysitters for people who do my job. But this idea is maybe we could grow up and be nice people ourselves. Would be wonderful. So that is what we're going to do. As a group, we are going to go through 4 or 5 slides. They will have checklists. We will know what to do whenever anyone comes along with a data analytics problem. So, yeah, this is the section with lists. There are no more cute photos. It's very sad. Okay, so when we're gathering requirements, we should gather requirements. That should be a thing that actually happens, especially as an engineer. When you're trying to do data analysis, sometimes someone will just go, hey, you know some of that statistics stuff, you did it in college, right, okay, so I want you to work on this particular piece of software, here's the spec, go ahead. Those aren't full requirements generally, and if you're a data analyst by profession, you don't usually have someone who's working with you to do requirements analysis, so do it yourself. So you want to work out, hey, what are we building, why are we building it, who's going to use it, who everyone involved is. You should write them down. This is really dumb stuff to say to engineers, but actually people don't write down the requirements for data analysis projects as much as they do for software engineering problems. And you should work out if there's a way to test it. I will get to this when I'm doing the tests, but testing it doesn't mean the p-value is wonderful. Testing it means, hey, I want you to analyze a bunch of software and I want you to tell me which people should be I work for Indeed, so should be offered this particular really cool job. The way to test that isn't, my model is super accurate and definitely super works. The way to test that is, the output of my model is actually people who want the job and are good at the job. Also, just side note, if you're working for Facebook or the military or something, and the requirement is build a killer robot, don't do that. Think it through. When you get your requirements, go, oh, those are terrible, and then just say no. The worst thing that will happen is that you'll have to find another job in an industry where everyone is trying to hire. Okay. Input and data validation is a bigger topic. So you're going to have to analyze your data somewhere. Generally, when you're given the problem, you don't already have a data source in mind. So you're going to have to go find it. If you're super lucky, there's a database somewhere. That's great. Hopefully it's documented, maybe even usefully. But you want to ask a couple of questions. So what is it? Like, is it actually numerical data? Is it images? Like, what does this thing look like? Because sometimes people want to analyze images when realistically, if they had a swipe card and looked at like a single metric, they'd be fine. Where does the data come from? Important because I'm in Ireland. And if I wanted to build software for people who happen to be in Ireland, but I'm taking all of my training data for my model from a different country entirely, kind of similar to localization, it's going to fit for that model. I run into this currently in work. So I work with customer services reps and sales reps, and people in different countries behave differently, which is impressive and amazing. That affects how your data is collected and how it's documented and what the data is actually measuring. You wanted to know who collected it and why they collected it. Sometimes this isn't particularly important, but like, if I collected the heights of everyone in this room to build a model to measure the heights of people, and then I built a classification system, it was wonderful. I labeled all of the people above my height, because I'm very average, as tall, and below my height as short. That's great. If you try to use that same data set to classify the heights of dogs, all of your dogs will be short. Then the last, actually, fresh. By fresh, I mean like, okay, if you're trying to predict something every week, your data should be updating every week, because otherwise you don't have enough recent data to do so. And how is your data biased? This could be an entire talk on its own. Your data is going to be biased, because you're a human and you can't sample the entire universe. And even if you could sample the entire universe, so much of it is dead. And that stuff happened in the past already, so you'd need actually to sample all of time and space. So if you're in Ireland and you're sending out surveys and doing A/B testing locally, that's wonderful. You're not going to get everyone speaking all of the languages. You're also going to kind of potentially miss edge cases. You can't really write... you could write a wrapper of software engineering around your model to try and catch all of the edge cases, but you need to know what samples of data you're missing. For example, for years, when people were doing research for computer vision to try and work out gender from face images, I was constantly classified as a 50-year-old man, because 50-year-old men wear dark-rimmed glasses. If I took off my glasses, I was then again a woman in my 20s or 30s. It was wonderful. So you can't avoid bias, but you should definitely write it down and try and mitigate for it. If you're not going to mitigate it for it, at least write it down so the people who fall into one of the buckets that are biased know that. And then, yeah, that's great. So we checked off all of the lists. We have wonderful data. We're going to do things in time. And when you're writing software and you've tested all of the potential options, if you've actually been like super thorough, those are all of the options that could possibly happen in the universe. If your data is measuring anything to do with humans, which is almost all data, it will change. And then some of these things will change. So you should probably put some monitoring around it. That can be really simple. It can be like, hey, I have a metric and it says we have the same amount of data all of the time. Our database hasn't gone on fire. Cool. It can be more complex and you can do automated statistical analysis. It's up to you. It depends on what your problem is. But you should definitely do it. Okay, that's the wrong way again. I'm very bad at slides. Okay, I have 2 slides on then model selection and how to actually do the stuff. This is all apparently the cool stuff that people wanted to work on. It's the stuff where you can do, oh yes, I know how a machine learning model works. I can put data science on my CV. So feature selection is, I have all of my data, which are the important bits of the data, which pieces are the most important for my classification or my prediction. So I have your entire Facebook profile, but in order to determine if you're sad, I just need to work out how many times you used sad words in your posts. If you're doing deep learning, you don't do feature selection. It is part of the model. A lot of deep learning models are meant for image data. So, okay, if you're analyzing images or audio or other signal analysis, you can maybe skip this step. But even if you're doing that, unless it's very complicated to produce features, you should produce them for your own understanding of the data set, because you should never be trying to write a model not understanding what your data is. Then you need to ask, do humans need to understand the model? So this is probably a problem with the target one, internally in target, because if I have a neural network, it's a black box. I put numbers in, other fancy numbers come out. It is wonderful, the numbers are always correct, except when they're too correct and then they freak everyone else out on the news. There are some models that you can use that will kind of give you a breakdown. So if you use a decision tree, it's going to take all of your data, go, the data with this classification, that's on one side and that's on the other. So if you were trying to do the heights of everyone, it would take, no, not the heights, that's too simple. If it was trying to do the gender of everyone, it would take your height as one of the metrics. It would go, okay, if you're tall, you're slightly more likely to be a guy, so I'm going to put you in this bucket. And if you're a girl, the other side. And then it would go, okay, well, do you have a mustache? You're pretty much a guy. So like, but you might be a tall girl. And it will sort it out and it will print out, hey, these are the problems. As a data analyst, if people need to know what your model's doing, you should use a model like that. If someone's insisting that you, or if someone's insisting, or if a black box model is better, I've put a link here. There is a framework called Lime, and it's a piece of statistical software that wraps black box models, and it tries to explain after the fact why a black box came up with that sort of solution. Worst case scenario. And then last one for model selection, which I was talking about with the target example as well. You are going to have errors because your computer is not perfect. Unless you're trying to like predict an AND gate or something, which, why are you using machine learning or data analysis for that? So sometimes you're going to get the right answer and it's going to be positive, and that's wonderful. Sometimes you're going to get the right answer and it's negative, and that's going to be great. And sometimes you're going to say, no, there's like this is a false thing, but it's going to actually be positive, and vice versa. So when we were trying to determine like how to send marketing information that was to do with pregnancy, you don't like assume women are pregnant in real life. They get quite offended. Your computers also shouldn't do it. So if you're building a model that is going to have an output dependent on pregnancy, you should change the model so that it, only if it is very sure, like the computer equivalent of the woman has told you, only then should you go, hey, do you want to buy baby formula? So if you're going to have errors, you're going to need to at least have a decision about which one would be better to bias for, and then actually the tech behind it is relatively easy. Okay, and then for testing. So I didn't go through this one in the examples from the news because it doesn't make it into the news when you mess up your testing. It just makes it really hard to understand where your bugs are and why everything's broken. You're going to have two kinds of testing. You're going to have the testing where, yes, my model works, and you're going to have the testing where, oh, and it did the right thing. That's much better. You needed to have actually done the requirements gathering in order for testing whether or not it did the right thing. So you should have done that already. If you don't do both of these things, you end up saying, my model is super, super accurate. It has like a really, really good prediction score. Everything is wonderful. So I'll build a model that will predict house prices, and it'll be great. It's super easy regression. If the houses are bigger, they are more expensive. If the houses are close to town, they are more expensive. If you live in Ireland, the houses are more expensive. You can't use the same model to predict occupancy. You can't say if the house is more expensive, more people live there, because fancy people like having big houses. But frequently you'll get someone who builds entirely the wrong model, answers the wrong question, but they will report in their testing, all of their testing is to do with accuracy, and then you deploy it and customers are very confused. Okay, so I think if we do all of these things, so if we work out what we're going to build, and then we make sure that we are building it from stuff that is not junk, we build it in such a way that it's not horribly broken, and then we test that it is both working and doing the right thing, we also have to do this. if you get a bizarre question, like a bizarre requirement, you should work out why you're being asked for that. Sometimes it goes back to, like, hey, we hired a bunch of researchers. We should do something cool with them. Please make a cool thing, which may be a valid concern if you want to do marketing, but probably shouldn't be your entire driving force. Sometimes it's because whoever's in charge of the analytics budget really has a fun pet project. Most of the time it's not, but you will get weird requests, and you should question them. And then, hopefully, you will also do the ethics question. When I was thinking of this talk, I was going to think through, oh, okay, well, we'll just think when I get a weird request and when I have to build an entire model, I'm going to go through, hey, these are the questions to ask yourself. And then I obsessively watched all of The Good Place, and now I can't understand how philosophy or ethics works anymore. But you should ask the questions. When you're asked to build an automated system, it's going to affect human behavior generally. Even if the human behavior it affects is the CEO saw a report and now has a different business decision. Because otherwise you probably shouldn't be doing analysis if no one's going to see it. And you need to make the decision, okay, I'm making this model. What happens if I make it this way? What happens if I make it the other way? And like, okay, cool. Maybe when we have driverless cars, we will hit fewer people, but you still might feel really bad about that. And you might want to think it through. When I was working previously in medicine, it was kind of like, okay, well, I could make this highly accurate, but I won't know when I can't find the problem anymore. Or I can make it less accurate, and I will definitely know when I should refer to a doctor. So, like, think through the things. When it's deployed, what effect will it have on people? And, you know, ethics. It'll be great. Okay, I think you're all super totally responsible data analysts now. And you should all watch The Good Place, because then you will be good people. Thank you. Also, you can ask me questions now. Or you can all eat. Oh!
I don't know if this is like a good question or not, but I was wondering, does it ever happen that you collect data and at one point, does the data that you started collecting become, I don't know, irrelevant? Do you remove it? Do you keep all the data just to like get a larger database? I don't know if...
Yeah, so it depends on your use case, but under GDPR you should definitely know the answer to that and write it down because legal reasons. So generally, yes, data does age. If I'm trying to predict people's heights, I only want to go back the last couple of decades because people ate terribly beforehand. If I want to predict customer behavior, I really only want to go back to the last major deploy because before that they were using a different product. So it changes per application, but you will always have a date where you should throw all of the stuff away, unless you're doing like anthropology or history. As a tech person, you should always throw some of the data away. It will age horribly. More people. Is there delicious chats and food later? Is that why no one wants to talk? Okay. Cool.
Thank you so much, Maria.
Cool. Thank you.
So that's the end of our Tech Talk night. Thanks all the speakers for coming and for putting time and efforts into their amazing presentation. Thank you also to all the volunteers. And thank you everyone for coming. If you want to become a speaker for a future event, please fill the form on the Meetup website or please come talk to us. And yeah, have a good rest of